Our new topic is on triangles and trigonometry. Now, we've done trigonometry before, so this is not new to you. So what we need to do is try and take it a little bit further, and we're going to revisit some of the original ideas we've had with trigonometry, but then we want to take it further to non-right angled triangles, and we also want to have a look at special relationships that are going to exist, as well as start to solve more in-depth equations involving trigonometry. Now, this is only part of the trigonometry in the 2-unit course. We do more trigonometry in the HSC part, so this is the stuff that's in the prelim. So remembering what we've had before. Now, we know in a right angled triangle we have three sides, and the largest side being the hypotenuse, and the other two, we have the other two sides. Now, what we've done, we're always going to label one of our angles that's not a right angle. Now, in relation to this angle, we're going to have an opposite side and we're going to have an adjacent. The opposite is obviously opposite that angle, and the adjacent is next to that angle. So that's where we get our opposite and adjacent. If we put theta up here, our opposite and adjacent sides swap around. So that's the first thing we need to be able to identify and look at our triangle. Now, if we have a look here, we've got three sides, which means when we look at the ratios of those three sides, then we'll have 6 different ratios. So the opposite, hypotenuse, adjacent, hypotenuse, opposite, adjacent, and then reverse them, adjacent, opposite, adjacent, hypotenuse and adjacent, hypotenuse and opposite. So we have 6 different situations which we've got up here. Now, we're going to give those special names. Now, what we're talking about is the situation though, no matter what size our triangle is, if that angle remains the same, these sides will always be in the same ratio. So if that's 30 degrees, the sides are in a particular ratio. If it's 59 degrees, the sides are in a particular ratio. If the angle there is 21 degrees, those sides in a particular ratio, depending on the size of the angle there. Obviously that angle would be affected as well, because the two of those add up to 90 degrees. But as long as we've got a similar triangle, the sides are going to be in the same ratios. So that's where we're going to be able to do that, and you've used that before, hopefully, in with right angled triangles. Now, what are our ratios called? Well, we've got definitions for these names. So when we have the opposite side over the hypotenuse, we call that the sine ratio. If we've got the adjacent side and we put that over the hypotenuse, we call that the cosine ratio. And the opposite over the adjacent side, we call the tan ratio. So we've got our 3 main ratios that we deal with. Now, they're the ones you see on your calculator. So on your calculator, you'll see a sine, cos, and tan button. So hopefully this is not anything new to you. But the opposite on the hypotenuse is in a particular order. What if it was the hypotenuse on the opposite? Well, we define that as the cosecant of that angle. Hypotenuse on the adjacent would be the secant of that angle, and adjacent on the opposite is called the cotangent of that ratio. So there's our 6 different combinations we can get with those 3 sides and the names that we give them. Now, these 3 sides, these 3 ratios here are often called the reciprocal ratios, because they are reciprocals of sine, cos, and tan. So they are the reciprocals there. We take the reciprocal of sine, we get cosecant, and that's how we can write that relationship. So cosec theta is equal to 1 on sine theta, or sine theta is equal to 1 on cosec. But we can swap them around, and that's legitimate. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So we were able to get that. So you've got to remember that the relationships that exist between those sides in right angled triangles. And we'll do much more with all 6 as we go through this topic. Other things we need to remember from previous work done: angles of elevation, angle depression. So for an angle of elevation, basically you are in a situation where we are looking from a horizontal, we look up, and the angle that we look up there is called our angle of elevation. Angle of depression is where we're on a horizontal and we look down, and the angle there would be our angle of depression. So that where you see those 2 terms in problems, that's what we're talking about. Compass bearings. So compass bearings we use north, south, east, west, and all the variants in between. So if we're looking at something like that, that would be north of, if this is northeast, halfway through, this would be north of, northeast. So again, you've played around with compass bearings. More likely we're going to deal with true bearings. Now true bearings, situation where we claim north to be 0, 0, 0 degrees, south, east would be 0, 9, 0, south would be 180, and west would be 270. Now notice I'm not saying 270, I'm saying 270. We like to give it a 3-digit representation no matter where it is. So an angle there would be 0, 4, 3 degrees. So we give that a representation there. Down here we'd have 1, 9, 8 degrees. So that's where our representation would be, somewhere in the 0 to 360 degrees, but we give it a 3-digit representation there. So there's stuff you should have seen before. If you're not too sure about it, you need to review it, you need to be good at it, because a lot of the problems you're going to get are involved with it. Some of the other things you're going to see, well, write cosine theta as a fraction. So the question's here. When we look at cosine of theta, we need to look at what's cos of theta. Now, hopefully you're saying, oh, wait on, you didn't talk about SOHCAHTOA. And so, well, let's talk about what does SOHCAHTOA mean. The sine is the opposite over the hypotenuse, cosine is the adjacent on the hypotenuse, TOA is the tangent, is the opposite over adjacent. So that's where we have a little mnemonic there to remember what our 3 main ratios are. So cos of theta, I'm looking for the adjacent side and the hypotenuse. So I've got the A, I've got the B, the adjacent side's A, hypotenuse is B, so I get A on B. This work here is all done with your calculator. So if you throw in those in the calculator, hopefully they match up to all these answers there. And these are typical of some of the calculations you're going to have to do to solve problems. Cos 70 degrees and sine 20 degrees. Well, hopefully if you put them into the calculator, you realise, wait on, they're the same. But also if you look here, we've got 70 degrees there and 20 degrees there, and have that as A, B and C. Cos of 70 would be the B on C, which is the adjacent on the hypotenuse, and sine of 20 would be the opposite, which is B. So what's the adjacent for 70 is the opposite for 20. This is displaying what we call a complementary angle rule, and we'll see more of this. We'll explain this a little bit more in depth later on. But there's a relation. They're both equal to B on C, so they give us the same. You throw both into your calculator, it will give you the same. So, and then we'll see that cos of 40 there would be equal to sine of 50. Writing these ones, again, these are something we're going to do more of later on. We're dealing with exact values. So we're going to do dealing with square roots a lot in this one. So for that triangle, cos of 30 is the adjacent, which is root 3 over the 2, which is the hypotenuse. Tan of 30 is the opposite on the adjacent, so that's where the 1 on root 3 comes from. Remember on your calculator when you're doing this one, we're going to use our inverse tan. Now the inverse button, inverse tan, so the tan to the power minus 1, our shift tan, is the idea of taking the opposite of the tangent. Now when we take tan of an angle, we get a ratio. So when we work backwards, we take inverse tan of the ratio, and that will give us our angle there when we calculate it. But that's all we need to do is shift tan and then put these numbers in, and that will give us our angles there. Drawing a bearing of 200 degrees, not 200. So we know north was 0, so we know that's going to be 0 degrees there, or 0, 0, 0, and south is 180 degrees. So 200 will be a little bit on from 180. So it'll be somewhere around there. So again, we're not looking for total accuracy. If you want to get your protractor and measure it out, and you can do all that, but we're looking at it should be somewhere in that direction there. And again, two of the calculations we're going to see later on doing these substitutions. Remember, when we want to solve these equations, we need to have these values for A, B and C as angles. So there's another couple of rules we'll look at later on with non-right angle triangle trigonometry. So there's some of the things you need to do. Be able to remember all your ratios in right angle triangles. Be able to identify which ratios are which, and which sides have relationships to which ratios. But also be able to use the calculator and be able to do those calculations without making any errors. So we're making sure we substitute and put those into our calculation in our calculator correctly.